Hello, everybody. Good evening. Good afternoon. I am Mr. Lee. We are going to do revision for Form 4, Chapter 6, Light and Optic. So this is what you request. Before we start, the first thing that I want you to help me to do is help me to press the like button and subscribe button. And then second one, it is, do you see the link that I sent here? This is my Telegram group. If you got any question that you want to ask, you can ask. If you are not my student, meaning that if you are not joining my tuition, so you can ask in the Telegram group. So if you are my student, you can ask me directly through WhatsApp. I will answer you lah. All right. So let's go. All right. 6.1 reflection of light. So I will go slightly faster. 6.1 reflection of light occur due to the change in the velocity of light when it travels through the different optical density medium. Meaning that when the light go into here from the A to the glass, all right, different medium, so it will be bent. Why it is bent? Because of the difference in velocity. The velocity change, right? So when the velocity change, the direction will change. So you need to know how to draw the direction. Okay. Now, first one you need to know is when the light travel from less than to denser. Less than mean kurang tumpat. Kurang tumpat to tumpat. Right? The less dense to denser. So it will bend toward normal. So you can see this I is more than R. So it will bend toward normal. So what is mean by bend toward normal is supposed to go straight, right? So go straight, right? So it bend near to the normal. Near to this normal here. Right? This is the normal line. So you need to know where is the normal line. Right? Normal line, it is 90 degree to the entry point. Right here. 90 degree to the surface. All right. Now, when the light travel from denser to less than, it will bend away from normal, meaning that it will not go straight. It will not go straight. It will not go straight. It will bend away from normal. Okay, it will bend away from normal. So you can see this value, it is greater than this value. Of course, you ask me, teacher, this one wrong, right? Where? So you said I is more than R. You see this I is smaller. So this is the incident. This is the reflected ray. So but when we calculate, we always take the bigger number over the smaller number. So I is always bigger than R. So in the calculation, we are going to take this one as I and this one as R. Right? No need to worry. This one is not wrong. Okay. Now, after that, you need to know how to draw. So I will try to do some very fast. If you got question, just stop and pick up. Tell me where is your question? What's your question? So when you draw here, so you need to know where is the normal line. All right, this is normal line. So what happened is the light travel into the glass, so it will bend toward normal. Less than to denser, toward normal. Okay, the light travel here out from glass to the A, so it will bend away from normal. All right, so this is your answer. So the light go into the glass. What happened is now it will not go straight. It will bend toward normal. A to the glass toward normal. Right. So now this one it is. Alright, this one it is when the light travel from here, from the glass to the A. So it will be away from normal. Okay, away from normal. How much is this away from normal? Normal drawing without calculation, we don't care. Alright, we don't care. So when the glass travel perpendicularly, so this one you have to be careful. So this one is 90 degree. When you see 90 degree travel in, so it will not bend. It will go straight. Right? 90 degree. So now when it travel into this kind, so your normal is like here. Wait. Your normal is something like here. So remember, your normal is always 90 degree to the surface. Right? So first of all, now it will not go straight. It will bend toward normal. Okay? So when the light travel out from the prism to outside, so what will happen? What will happen is it bend denser to less than, it is away from normal. So you will see something like this. Okay. Now, when the light travel from here, right, to the converging lens, so what happened is, this is your tangent, this is your normal, right? So the light will not go straight, it will bend toward normal. How about when it go out? This is your tangent, this is your normal. So it will not go straight, it will bend away from normal. So now what you see is, it will be, another word, it will be bending like here. It will bending like here. So this one is your focal point. Right? This one we call it as focal point. Right? Same as here. This one, how it is work? So this is your tangent, this is your normal. It will bend toward normal. It will bend toward normal. You bend toward normal. This is your tangent, this is your normal. You bend away from normal. Right? That's how it happened. Alright. So now the second thing that you need to know, it is Snell law. Snell law, the formula that we use is n1 sine theta is equal to n2 sine theta 2. n1 sine theta 1 is equal to n2 sine theta 2. For example, we got two medium here. Alright. So how do we do it? So n1 sine theta 1 is equal to n2 sine theta 2. n1, it is the medium one, right? 1.33. Sine theta. So z, this one 45. So this one going to be 45. Alright. So sine 45. N2 is this medium. N2 1.5. Right. Sine theta 2 you don't know. So you want to calculate the sine theta. So how much is the theta? So now 1.33 times sine 45, 1.33 times sine 45 divided by 1.5 equal. So you get this sine theta. So you want to find theta, shift sine, it will get your answer 38.8. So theta will get you 38.8. Normally we are going to get 2 decimal at 3 degree. Right, that's all. Okay. This one, because of these notes, I don't want to write anything into here, so I'm using I don't save my writing into here, my notes here. Alright, so I want to keep it as clean notes. This one is for my Form 4 use. Alright, so this one is an exercise. We try to do some. Alright, for example, which light ray ABCD is correct? Right? So you need to see, this is a glass, this is water. So this is denser. This is less dense. Right? Denser to less than, it is away. So when the light travel from here to here, so it will not go straight. It will be away from normal. So the best answer will be D. The best answer will be D. Right? Why? This is not A. See carefully. So most of you, teacher, this one A to the water, so toward normal. No, this one is wrong. So you need to be careful. Which one denser, which one is less than. and then calculate the refractive index of the glass block. So now what do you need to do is, first of all, draw the normal line. Draw the normal line. So this one is your incident angle. Alright. This one is your reflected angle. So n is equals to sine I over sine R. Okay, I haven't teach you this. N is equal to sine I over sine R. Snell rule also. Right? Sine I over sine R. Right? N is sine I over sine R. I is 150 minus 90. This is 90. 150 minus 90. It is equivalent to sine 60 over here. 125 minus 90. It is sine 35. So sine 60 divided by sine 35, you will get 1.51. Alright, 1.51. Answer is A. N is equal to 1.51. Answer, it is A. Okay, so now for those who just joined, alright, please know that that one, the one in my chat there, it is my Telegram group. Right, if you were not my student, meaning that you don't join my tuition, now you also can ask me question, but I seldom see Telegram group lah. Telegram chat, I seldom see, so maybe I will reply you that, right? Not as fast as I reply in WhatsApp group. Okay, this is all the exercises. I'm gonna skip. All right, I'm gonna skip. Because of I'm doing revision, I am going to do fast. Okay, so this is all the exercises. I'm going to skip. Now remember, when you do calculation, one thing that you need to know, when you do calculation, the most important thing is, now for example, this question, okay, what you need to do is, you draw normal line first. Right, so now n is equal to sine I over sine R. I is always bigger than R. I is always bigger than R. So you take 65. No. So you have to be careful is, what do you need to be careful is, the I and R must be bounded between the incident ray to the normal and reflected ray to the normal. Okay, be careful. So now you need to calculate this angle. And then you always use the big number over the small number. Right? Don't use the small number over the big number. So for example, this one is 90. This angle, it is 90 minus 32, which is 50. No, 48. No, 58. 58, right? 58. 58. So this angle is 90 minus 65, which is 25 degree. So what you need to do is sine 58 over sine 25. That's your answer. Okay, and no unit. Refractive index, no unit. Okay, this is the thing that you need to take care. For example, this kind of question, now you see, this is most of the students get wrong. Okay, now n is equals to sine I over sine R, and they said n is 1.33. Sine I over sine R, right? Most of you will take, sine I is incident angle. Okay, 1.33 is sine 30. Sine 30 divided by sine S. Alright, and then this one go up, 1.33 go down. Sine S is equals to sine 30 divided by 1.33. This is wrong. Okay, so never mind. We try to have a look into the answer. So sine 30 divided by 1.33. Sine 30 divided by 1.33. And then what do you need to do is shift sign. Shift sign. So 22.08. Oh, teacher, 22.1. Alright, this is wrong. Why? Why? You see, this angle is 30. Alright, from water to the air. So when the light travel from denser to less than, it is going to go away from normal. It is not going to go straight. It went away from normal, meaning that this angle have to be bigger than 30. So if you say your angle, it is like S is equal to 22.1 degree. So it is logic or not? Not logic. So what's wrong? How to do it rightly? So now how do you need to do it rightly? Is N is the sine I over sine R. Right? N is 1.33. Sine I always the bigger number. You try to have a look is this 30, this S. Which one it is bigger? Of course, S it is bigger. So sine S over sine 30. Right? Sine 30 go up. Sine S is equals to 1.33 times sine 30. 1.33 times sine 30. Right? 0.665. So you want to find S, you need to shift sign. Alright, you press shift, sign, answer. Right, 41.6 at 41.7. 41.7 degree. Okay, so answer should be B. It is not A. Alright, this is commonly students do it wrongly. Right, this one is wrong. Be careful. This one is salah. Don't use it. Alright. So this is all the exercises, and I don't want to do it because of too much. Alright, I do revision only. If you got question, you can ask me. You just see. You just watch this one. Alright. Okay. Now I go for 6.2 already. Now total. No. Still got two formula I haven't teach yet. Yeah, I still got two more formula I haven't teach. These two, right? Cannot skip that fast. But okay. Now the second formula is N is equals to real depth over apparent depth. Alright, real depth we are going to put the big H, small apparent depth we are going to put the small H. Alright, so always use big over small. Always use big over small. Okay, so what is real depth? Real depth must be the object to the surface of the water. Alright, this is real depth. This is called the fact one, the position of the image of the fish. It is small h, right? Apparent depth, right? Big divided by small. Okay. All right. Now, real depth over apparent depth. And for example, I take one example from here. Okay. This example only, and one example only. So what is the real depth of the fish if the fish is seen at 1.4? So N is equal to real depth over apparent depth, right? The refractive index of the water, it is 1.33. Now real depth of the water, it is 1.4, right? What? Oh, this one is not 1.4, sorry. This one is seen at, mean it is apparent depth. So this one is H, this one is 1.4. So 1.4, time it up. You're gonna get H is equal to 1.33. 1.33 times 1.4. So the answer will be 1.33 times 1.4. So the answer will be 1.862, right, in meter. Okay. Now this part, the thing that student commonly get wrong, it is okay. For example, this question. So n is equal to real depth over apparent depth. So real depth is from the coin to the surface of water. Okay, it is 1.4 plus 0.6. It is 1.4 plus 0.6. Apparent depth, it is from image to the surface, right? Image to the surface, it is 1.4. Now, don't confuse here, because sometimes they will give you this, right? They will give you the question like something like this. Okay, for example, like that, right? Find the apparent depth. Student cannot do already. So, reflective index is 1.5. It is because real depth. Real depth is here. Over apparent depth is here. Now, how to do, teacher? I don't have it. Okay, so never mind. You're gonna put it as H, right? So it is find the apparent depth. Find the apparent depth. Apparent depth, I put it as H. 1.5 is equal to real depth H apparent depth plus 0.5. H plus 0.5 over apparent depth H. So you time it up, then you can do already. Right? So 1.5 H is equal to H plus 0.5. You move this one to here, minus H. 1.5 minus 1 H, it is left 0.5 H is equal to 0.5. So H can be 1. Unit E, it is in meter. Okay, this is how you do it. Right, be careful. Now, the third formula that you have is here. N is equal to speed of the light in vacuum over the speed of the light in medium. For example, I take this one as an example. Now, find the reflective index if the speed of the light in the medium it is 2.68 times 10^8, and the speed of the light in vacuum is this. So, N is the speed of the light in vacuum over the speed of the light in medium. So, always big over small. Always. So, now 3 times 10^8 divided by 2.67 times 10^8. So what we have is 3 divided by 2.67, right? 3 divided by 2.67. So you get 1.12, right? So to the power 8, I cancel lah, right? So I get 1.12. Right, 1.123. 1.124. Okay, no unit no unit So no unit Okay. Now exercises, I am not going to do it. Maybe I'll pick up some lah. Maybe lah. Right. For example, this kind of question. I want to try this kind of question. Right. This one. So diagram 7 shows the light from the air undergo the reflection under the light enter the water and perspective. So the reflective index is 1.33 and 1.55. So this is N1 sine theta 1 is equal to N2 sine theta 2. Right? N1, the first one, N1. N1, it is 1.33. Right? So the A is 1.33. Not A. Water 1.33. Okay, and then water here it is 50, sine 50. N2 is 1.5. Sine theta 2, I don't know. Alright, so you press calculator, this one times this one, divide by this one. So shift theta, then you get the answer. Shift sine, you get the answer. 1.33 times sine 50 divided by 1.5 equal, then shift sine equal. So 42.8. Right, 42.78. Answer is D. All right, not very hard. All right, you need to know which formula you gotta use. Okay, so this is all the exercises I have edited lah. We are not going to do it. If I do it, I will take a lot of time. Here, maybe we discuss some. Okay, discuss only. So, for example, diagram 2.1 shows a student observing a pencil inside the cup. The pencil appears to be bent due to the phenomenon of reflection of light. So, what is the meaning of reflection of light? Okay, what is the meaning? So, it is the bending of the direction of the light when the light travels to the different optical density due to the change of the velocity. You need to write velocity change, change direction, and bend. Okay, explain how the phenomena 2.1 occur. Explain how the phenomena 2.1 occur. I don't know how to answer this kind of question. Too much. So what you need to do is reflective index. What I say, reflective index of water and air are different. Alright, so it might give you 1 mark. So the velocity of light change when it travels from water to the air. So the direction of the direction of the light, right? Direction change. So the direction of the light change. Okay, now this is my answer. We try to have a look into the answer. Terengganu paper 2. Terengganu 2023. Question number 2. Here. Okay. Now the answer is 2 mark. So you got 1, 2, 3, 4 marks. So you choose 2 only. So the light move from the high optical density to the low optical density. I just said their density is different. So different. So the light will be reflected away from normal line. I didn't say this. The speed of the light in the air is greater than the speed of light in water. I didn't have it. So the incident angle is less than reflected angle. I get 0 mark from here. So they want the speed. They want toward normal or away from normal. Okay. What I answer is explain how is this occur. But their answer seems to be why it is away from normal. Why it is like that. Right? Why it is like that. Okay. Now never mind. Leave it. Normally this kind of question very hard to get mark one, right? You need to be very accurate to the answer, then you will get a mark. Okay, so I am gonna skip this one. So we go to 6.2. Right? I'm going to do it fast. So 6.2 total internal reflection, right? So what is total internal reflection? So total internal reflection occur when the light travel from denser to less than, remember, and the incident angle is more than the critical angle, right? So it will happen. Now, the first thing is n is equal to 1 over sine c. N is equal to 1 over sine c. Right? C is critical angle. Right? Critical angle is the angle that if the light travel from here, from denser to less than, it will go 90 degree to the normal. Right? This angle, it is called critical angle. Critical angle, Is more than critical angle, total internal reflection gonna occur. So for example, find the critical angle of the water. So what you need to do is n is equals to 1 over sine c. And 1.33 is equals to 1 over sine c. Sine c go up, 1.33 go down. Sine c is equals to 1 over 1.33. C is equals to, normally for water, it is about 42. Right? 41.8, 42 lah. 1 divided by 1.33 equal shift sign equal. So you got 48.7. 48.75 degree. Right? This is your critical angle. Okay? Alright. Now, this kind of question, you need to be very careful, which is, now find the reflective index of the prism. You see the light travel from here, this one is 45, meaning that this angle is 45, meaning that this angle is incident angle. The incident angle cause the light go up to here, right? Go to here. So this one is mean it is critical angle. So n is equals to 1 over sine c. 1 over sine 45. That is your answer. Okay, you can find the reflective index also. Now, come to the next one. It is called total internal reflection. Right? Total internal reflection, two things. If this question asks, the thing surely asks you about these two things. So, one is critical incident angle must be more than critical angle. And then the light must be travel from denser to less than medium. Denser to less than medium. Okay? Now, for example, how it is work, right? How it is work. So the light travel from here, and then you go away from normal, right? But if you increase the angle, you increase your incident angle, right? So this one will going down. If you increase again until here, so this one will come to here. So this angle, it is called critical angle. This angle like that is called critical angle. Right? This angle, not this angle. This angle is called critical angle. If this angle right here, you add more, increase more. So total internal reflection gonna occur. Total internal reflection gonna occur. Okay. Alright. So now given the n is equal to 1.5, find the value of critical angle and complete the drawing of the light ray above. So how to do this kind of question? N is equal to 1 over sine c. I want to find critical angle. N is 1.5. 1 over sine c. C is 1 divided by 1.5 and then shift sign. 1 divided by 1.5 and then shift sign. So 41.81. 41.81. So the incident angle is already more than the critical angle. And then, first thing, Second thing is the light ray travel from denser to less than, glass to the A. So what gonna happen? Right? Total internal reflection gonna occur. And this angle must be equal to 50 also. Alright? Must be equal to 50. Alright? Total internal reflection occur. Now, okay. I draw one only. Complete the drawing if the refractive index is 1.56. Alright? N is equal to 1 over sine C. And N 1.56. We can find critical angle. C is 1 divided by 1.56 equal shift sine equal 39.86. At 7, sorry. Okay, so you see this angle is 42. Follow this angle. Right? So now this angle is already more than 39. So what gonna happen? Total internal reflection gonna happen. So what is this angle? This angle is 42. This angle is 42 mean this one is 48. If this one is 48, I can find this angle. 48, 68. 48 plus 68 equal minus 180. So this angle is 64. This angle is 64. I'm sorry. This angle is 64. So 90 minus 64, you will get this angle. Right? So I just plus 90. So I got 26. Here it is 26. So the light ray travel from less denser to less than, and then less than critical angle. So what gonna happen? You bend away from normal. That's all. Right? This is how you're gonna do. Right? Okay. In the daily life, there is a few use of the total internal reflection or natural phenomena involve total internal reflection. This one commonly asked in essay question with the format one. So you need to memorize this. If you can memorize it. Right? Formation of rainbow. First one, when the light travels from the sun enter the water droplet, the light experiences a reflection and disperse into the different color. Meaning that the first one is the light go to here from less than to denser, so it will disperse. Disperse means it will change to many color. Why it change to many color? Because of the speed of the light are different with different wavelength. Okay, all these different color experience total internal reflection at 2 here. When the light travel from here, it want to go out, denser to less than cannot, total internal reflection cannot occur. And then the third one at here, the light reflect, experience the reflection and disperse against the moving, when moving from the water to the air. And then lastly, the color are rainbow are seen by the observer. There is format. So be careful. This one, it might come out if a say come out. Right? Very popular. If not, then this is the other one that is popular question. Right? Mirage. Right? Mirage. BM. BM we call Logamaya. Logamaya. Logamaya, BM, alright, mirage. So how is a mirage formed? So first one, it is here. The layer of the air above the rod are having the different optical density. So the layer of the air just above the rod, it is hot than the outer part of the layer. So the hot air has a smaller optical density than cold air. So the important thing is hot air here at the surface of the rod has smaller optical density, right? Different optical density, right? The second one is the light travel from upper layer to the lower layer that is gradually reflected away from normal, right? Away from normal. How it is away from normal? So the light come to here, right? Because of denser to less than, it is away, right? Here, the light travel from here. Let's say this is normal. It will not go straight. It will bend away from normal. Light, it will not go straight here. It will bend away from normal, right? And then after that, if the incident angle more than critical angle, so here incident angle is more than already critical angle, total internal reflection gonna happen. So the reflected light ray are gradually reflected toward the normal and reach the observer eye. So the observer will see the image of the cloud as a puddle of water in the middle of the rod here. This is mirage. Okay, mirage. So now, I don't think this one will come out, alright. But in essay can, right? In structural question, I mean in format one, it will be too many marks for this kind of question. Too hard to explain, right? So this one you have to read through prism, periscope, optical fiber, and cat eye reflector. So all of these are important, alright, especially in essay. In essay, this one structural or essay very important. So you try to read through. You can try and read through. Here is too much, so I don't. Never mind lah. I explain. I explain a little bit. So you can use to see the object behind the barrier. Alright, if something blocked, then this is a barrier. Right, you can see at the back. So made up of two right angle prism and both are end of the long tube. So now and then here it is a prism. Here it is a prism. Right? This is your object. Object travel to here. So now this is the normal line. So it will not go straight. Total internal reflection occurs so that it will go down. So meaning that this one it is undergo total internal reflection at this point. Until here, total internal reflection occur at here. So that you will see. Right? You will see the image at here. Okay. And then what you need to know is finally the object form it is upright and same size. Upright and same size. Okay. Now, optical fiber, it is used in the telecommunication or medicine. Alright, so I guess this one you know a lot. Right, so it made from the, normally it is optical fiber, alright, plastic fiber. Pure glass, little. So there is two core here, right? They got one outer cladding and inner core, right? Remember, the light always travel from denser to less than, so total internal reflection happen. So the cladding here, now this is inner core, this is the outer cladding. So the light must be from here. Let's say the light from here travel to here, so must be denser to less than, so total internal reflection occur. So normally what they ask you is what is the density here? Compare the density here and here. They give you one table, right? Density. This one density how? So inner density how? Outer density how? So you need to know. So this one denser. Denser. This is less dense. Okay, the light must travel. You want total internal reflection to occur. The light must travel from denser to less dense. Denser to less dense. Mm. And then the cat eye reflector lah. Cat eye reflector is it is used at the middle of the rod there or side of the rod there. So you can see here, this is the cat eye reflector. Uh, um, maybe I give you one question to do before we discuss it. Let me choose. Okay. Mm. Okay, D. D. Uh, Diagram 11.4a shows the structure of optical fiber. In diagram 4.11.4b shows the light travel through the optical fiber. Use a appropriate physics concept suggest a modification can be made to the structure of the optical fiber in 11.4 to improve the effectiveness of the optical fiber in telecommunication system. State and explain the modification based on the number of optical fiber, the characteristic of the material, and the characteristic of the inner core. So this one is 10 marks. So this is 10 marks. So I give you 10 minutes, all right? You try to do it. So we are going to discuss after 10 minutes, all right? 10 minutes, then we discuss. All right, I'll see you later. And you try to do this question. All right. So we are going to answer this question. So, you use appropriate physics concept. um, Suggest a modification can be made to the structure of optical fiber in 11.4 to improve the effectiveness of the optical fiber in the telecommunication. So first one is, so we write here, characteristics reason. Right, first one, we talk about number of optical fiber, more number of optical fiber. Why? Can transmit more signal or more information also can. All right. The characteristic of the material. Okay, characteristics. Okay. Flexible. Right. Can bend can bend easily. And then low density, lighter. One more. Flexible, low density. One more. Strong, not break easily. Be careful when you use strong. Don't use the word of hard. Like if you are using glass it is hard, but it is not strong. Very easy to break. So be careful. Alright, next one, it is characteristic of the material already, and the characteristic of the inner core. So inner core with high optical density. Higher optical density. Why higher optical density? So your reason will be, so the total internal reflection can happen. Characteristic of the inner core. Characteristics, meaning that more than one. Inner core. Clear, right? Clear, and why it is clear? So why? So this inner core, if inside here got a lot of air bubble, like glass when they build it, if they're not building it correctly or properly, so they will produce air bubble. So the signal will be blocked. So can transfer a clearer signal. I mean clear inner core, clearer inner core. Okay. So I got 1, 2, 3, 4, 5, 6. So we try to have a look into the answer. We try to Kelantan 2024. Question number 11. Okay, this is paper 1. I want paper 2. Question number 11. Okay. Alright. Bilangan gentian optik banyak or besar. Alright. More number. Okay. Bawah banyak isyarat data. Can transfer more signal. Okay. First one is okay. Ketumpatan rendah, lebih ringan. So low density, lighter. Okay. Kelenturan gentian optik tinggi. So flexibility lah. So mudah dibengkok. Alright. Can bend easily. Okay. Kelenturan. Right. Flexibility high. So I should not write just flexible. I should write higher flexibility. Okay. So ketulinan. Right. Gentian optik tinggi. So more clearer inner tulin. Right. So kurang kehilangan tenaga. So reduce the signal loss. Right. Also can. This one same meaning. Can transfer clearer signal. Lebih terang. Image yang diperolehi lebih terang. So reka bentuk gentian optik halus dan serali. I don't have it. Right. So should be fine and parallel. So they can receive the signal simultaneously. Or image diperolehi lebih jelas. Also can. Now they got a lot of answer. Sebekas gentian optik. Alright. Banyak isyarat boleh dipantulkan. Sebekas mean come in bundle. Right. Bundle. Right. So more together. Jenis bagi teras dalam kaca. Kaca. It is glass. I don't write glass. So high density, inner core with higher optical density. So I write it to here. So the ketumpatan bahan bagi teras dalam tinggi. So I write it to here. Okay. So menghasilkan indeks biasan yang tinggi, mengurangkan sudut genting. Alright. So total internal reflection can happen. So reduce the critical angle so that the total internal reflection can happen. So indeks biasan bagi teras dalam yang tinggi. So kurang sudut genting, menghasilkan pantulan dalam penuh. Right? Menghasilkan pantulan dalam penuh. Right? Same thing as this one. So sudut genting bagi teras dalam yang kecil. So menghasilkan pantulan dalam penuh lebih cepat, lebih banyak dan berterusan. So the thing that I have is more optical fiber, yes. Flexibility, yes. Low density, yes. Strong, don't have. Right? Inner core, yes. Clearer, yes. So these one, all the explanation are okay. So how much should I get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 10. So just this one don't have mark. Right? Sorry, not this one. This is how we are going to score a full mark in the essay. Alright. Any question from here? Any question from here? You see, this is another kind of the question that is very popular to ask in the exam. So you see, how do they ask 10 mark? You are assigned to give a suggestion and characteristic of optical fiber so that you can use in the telecommunication and medicine. Explain your following aspect. Feature in optical fiber. Features. I don't know what to say. Right? I don't know. Right? Comparison between the refractive index inner core and outer core. Inner core must be higher density. Higher optical density. Outer core must be smaller optical density. Flexibility high. All right. Purity of the inner core, you see? Additional features. So this one normally additional features you can put in the camera, right? Put in the camera so that you can capture the image inside. So I don't know what is the feature optical fiber. I think it is the density, right? So density, the whole thing, the density have to be low, right? So we try to have a look into the answer. This kind of question, Selangor 2021, step 2. Question number 11. Okay. Now, Sebekas fiber optic mean bundle. They come in bundle, so more signal can be transmitted, can be reflected. More signal. The first one, the first one I get wrong already. The second one is inner core and outer core. So indeks biasan teras dalam lebih tinggi daripada lapisan luar. So pantulan dalam penuh can happen. Next one is kelenturan tinggi mudah dibengkok. Okay, so high flexibility lah, can be bent easily. We answered before. Keturunan dalam lebih tinggi, ya, I told you just now. Jarak penghantaran bertambah, reduce the signal loss. Oh, this one is last one, like what I told you is ciri tambahan is additional features is you add in camera, so you can see the internal organ is can be more clear. This one you can add in. Now, any question? Any question from here? Next week I am going to try. Not next week lah. Next lesson. If you want, you let me know. Okay, I will try to do some more revision here. Of course, I'm going to do it fast. If you got question you want to ask, you can send it to me or send it through the Telegram group. Send it through the WhatsApp group. I will answer you on the spot. I try to do it every Saturday. See whether I can do it or not. If I am free, then I'm going to do it. If I am not free, I'm sorry. Actually, today I plan to give you some quiz one, but not many of you joined. So I become lazy already. So if many of you join, I'll give you quiz. I'll make the lesson longer. All right. Any other question before I end the class? Next week, try next week. I'll try to do 6.3, 6.3, 6.4 for you. All right. So I am going to stop here. So hopefully you enjoy my lesson. Don't forget to press the like button and share to your friend that who is needed. And if you want, join my Telegram group. Right, that is the link up there. You can join. If you are not my student, you are my student. You got any question, then you can PM me directly. So I am going to stop here. I'll see you next lesson. Bye bye. Bye bye.